Our third way we can use is trigonometry. Trigonometry, I'm going to label this again, A prime, B prime, C prime. Trigonometry tells us if our trig ratios are equal, then our two triangles must be similar. Let's check them out. Let's just use A and A prime as our reference angle. So sine of angle A is equal to opposite over hypotenuse. Take a look at angle A. Oh, let's label our sides. We've already done these. 2, 1, and the square root of 5. And this is 4, 2, and the square root of 20, not 10. Square root of 20. So sine of angle A is equal to opposite over hypotenuse, which is 1 over the square root of 5, which is approximately 0.447. Sine of angle A prime is equal to 2 over the square root of 20, which is approximately 0.447. Put it in your calculator, you will see that. There's our first one. Let's try cosine. Cosine of angle A is adjacent over hypotenuse. Adjacent is 2 over hypotenuse, which is the square root of 5. That is approximately 0.894. Cosine of angle A prime is 4 over the square root of 20, which is approximately 0.894. Looking good. Last one, let's check tangent. Tangent of angle A is equal to opposite over adjacent, which is equal to 1 over 2, and that is equal to 0.5. Tangent of angle A prime is equal to 2 over 4, which is approximately 0.5. So now you've just checked all of your trig ratios, and you found that the trig ratio for all three trig ratios for angle A are identical to the trig ratios for angle A prime. Both of those are corresponding angles, and therefore our explanation will tell us that since the trig ratios of the two triangles are equal, the triangles must be similar. So there's our third way, and there's one more way, and I will do that right now. Last way to check it is to actually draw line segments from the COD through the vertices, and let's see if we end up with it matching all the vertices. Alright, A prime, B prime, C prime here again, and let's draw some lines. So I'm going to go from the COD. You got to be very precise on this if you use this option. Let me get that line to be a little thinner. So our first one looks like we go, I think the question itself did state, let's see, did it say the origin was the COD? Nope, it does not say the origin is the COD, so be careful because maybe that's not what the center of dilation is. Let's do the next one. Okay, and then last one, looking pretty good. So we can go through B, and that looks pretty good. So looks to me like we've got similar. Now this is not the preferred method because it's not very precise, but it is a way to prove similarity. So for calculations, draw segments through So I can't put a calculation, so I'm gonna write draw segments through corresponding vertices. They all intersect at exactly 0, 0. So our explanation is, since all three segments through corresponding vertices intersect at exactly one point, I'm going to just put 1.00. This is a dilation. So the two triangles are similar. So kind of what this does, class, is it actually uses the same reasoning that we were able to do transformations right here. We proved it was a dilation, and therefore we proved they are similar. In this case, we use a little different method to prove it is a dilation, so they are also proven to be similar triangles.